Hey, welcome everybody to Fine Tuning Fridays with Oxen.ai, where each week we show you the power of open source models and how they're being applied in the real world for real use cases. And today we get a peek behind the scenes of how some people here in LA, close to Hollywood, are applying AI. And we're lucky enough to have one of our friends, Bruce Allen, help us out with this one. Bruce is going to be the magic behind the workflow we're showing in Comfyui today, and he's worked on Hollywood level films and trailers such as the Marvel series and is very technical and capable on both the technology and art half. So seeing some of his workflows, I feel like he's a bit ahead of the curve and pushing the limits of what's possible. Bruce, I'll let you give a little intro of yourself and talk a little about the tool that you're building.
That's very kind. Thank you, Greg. And very charitable because everything is built on open source things that other people have discovered. And I mean, it's lovely how like all the stuff that people are finding out is new and exciting every month. So everything we're doing will be out of date next month. But yeah, the tool I'm building a thing called Conductor. It's like a new creative platform for editing, VFX, and AI. And we're at www.conductor.film, and we love Comfy, and we love the idea of training models yourself because like that's the beauty as an artist and a VFX artist. Like the joy comes in when you actually get in and start training the models. That's where you have real creative control and real creative freedom. And yeah, I mean, that's why we're so excited about Oxen, because that's something like every director I've shown this to gets really excited about. The moment they see, oh my gosh, you can start training the models, you can have creative control back. Like that's just magical to them. So yeah, we're very excited about what Greg is doing.
Awesome. Yeah, excited to work with you as well, Bruce. And this use case that we're going to be going over today actually was inspired by a director friend in the industry. We can't use his actual footage or film, but we can kind of walk you through the use case uh, and how it's kind of being applied in industry. So imagine that you're shooting a Hollywood film and you realize you have the actor wearing the wrong clothes in the scene. And if you were going to bring all the actors back in, if you were going to do a reshoot, that would be insanely expensive. If you wanted to do it all with CGI or a VFX artist, that's going to take a huge budget as well. And so the goal here is say you're working on Pulp Fiction back in the day and you wanted Samuel L. Jackson in a different jacket that you had here. Obviously, this could be applied for the scenario that we talked about before, or it could be just applied for like a fun Halloween hackathon or something like this. So, to start, let's watch this iconic scene from Pulp Fiction. If you haven't seen it, this is one of the most iconic parts. This guy comes in, takes a bunch of shots at them, misses, bunch of holes in the wall. They look at each other and proceed to take him out. All right. So for one, this scene is probably not something that you can run through the closed source models because of the content filters and other things that we have going on. So what we're going to do today is make it a bit fun and see if we can take another iconic scene of an actor. This is from Eddie Murphy's Delirious set, where he's got this crazy red jacket on and see if we can train a model to understand this specific red jacket and outfit and apply it to Samuel L. Jackson on the left here and hopefully make it really studio quality. So you'll notice things like this image on the right is a bit blurry. It's from like an older recording on YouTube, and the lighting is completely different between these two. But like, can we at least use this for training data to capture the essence of this jacket and apply it over here. And what we'll be working towards is this big Comfyui workflow that Bruce put together for us, and we'll be diving into each of the individual steps. But before we do that, I kind of want to motivate why why you need such a complex workflow, because um, it you might think that you can just start by prompting models or using Nano Banana and Quen Image Edit and stuff like this. And I just want to give you some failure cases before we dive into the actual end-to-end workflow to kind of motivate where we're going with this. So the first thing I tried was, okay, we have these image editing models. Can we take these two images and use them as context to a Nano Banana or a Quen image edit and replace the jacket in the scene to get the first frame and then extrapolate out from there? And right out of the gate, it does like a pretty good job. It definitely puts the jacket on the right person. It knows the context. But if you zoom in, one, the lighting is just completely off between these two, and two, this kind of looks like a video game character or something. Like it's super plasticky. This looks like it might be rendered with Unreal Engine or something like that. So the level of detail is definitely not something that you can get into a Hollywood film. But what is cool is you can even take frames like this and animate them with models like Wan. So this was just like the lowest hanging fruit. Can we make two API calls, run two models to swap the jacket and animate? And like, yeah, if you're not going studio quality and you just want to have fun, that worked pretty well. Um, and some creatives that I've been talking to actually spend a lot of time on just this step alone. Like, can you get a really good starting frame? Can you get a really good ending frame? And then can you animate it from there? I know, Bruce, you're a big fan of fine tuning. I don't know if this is a workflow that you do in your work, but do you want to talk a bit about the different options you have here and why you lean towards fine tuning?
Yeah, I think you summed it up. All these things are well and good until you need that extra control, and when you also need it consistent across multiple shots. And at that point, that they're just not designed for that. They're amazing and awesome and a cool demo, but they at that point you really need fine tuning for consistency and directability.
Totally. Um, so one of the models that we're really seeing artists have full control with is this Wan 2.1 VACE. And if you follow along with our Friday sessions, you'll know we like to get into the technical details of the model here. We won't spend too much time on it, but I just want to give you a bit of a timeline and a bit of context of where this Wan 2.1 VACE fits in. So back in the ancient days of AI of the early February and March of this year, Alibaba and Wan came out with their 2.1 series. And in March, this 2.1 base. Since then, there's been Wan 2.2, Wan 2.2 S to V, which is like an audio to video, and even a Wan 2.2 animate. But none of them really have the creative control of this Wan 2.1 base. And if you look at the research paper, even the very first graphic that they have in here, their goal is really this unified generation and editing tool in one. So it's everything from taking a reference video or reference images and generating video from it to having a pose model in the loop where you're passing pose through and that's driving the characters in the scene to structured control via depth or via like a sketch. Um, and then they have really cool workflows that we're going to be using, like this masked video to video, so that you can kind of mask out just what you want to change in the frame, keep all the other pixels the same, and then have the model focus on the specific region of the video that you want to edit. And it's really cool how many tasks this kind of enables. So with the basic building blocks of like reference to video, video to video, mask to video. You can do all sorts of different composition or swapping out characters or expanding frames or animating things or moving things. So it's really this like Swiss Army knife of a model that you can use. Um, One thing that I thought was interesting if you dig into the model details is if you are somebody who's interested in training models, there's kind of two strategies that they talk about of having this context injected into the model. You can either fully fine tune the model where you like concatenate and add together the tokens for the context and the video and then fine tune the entire thing end to end. They actually experimented with a slightly different approach where they separated out the context weights from the diffusion transformer itself so that you could, they called it concept decoupling, so that you could train like the masking concept and you could train the pose estimation concept and you could train the whatever concept separately, and then you can kind of like inject those into the diffusion blocks themselves. And I thought it was super interesting if you look at the graphs later in the paper. I would have expected the full fine tuning to perform better, but actually, this context adapter fine tuning trained better, trained faster, and they even experimented with like, do we inject at every single diffusion transformer layer or do we do individual layers? So if you're interested in all the details there, the paper is super interesting. And I'm kind of waiting for whoever releases the Wan 2.2 VACE version because we kind of have this Swiss Army knife for 2.1. Curious if Wan is working on the 2.2 or not. So, with that said, let's break down this workflow and let's talk about the different inputs in the context of this tool that can take in a lot of different inputs and how we're going to chain them together in a Comfyui workflow. So let's start with the reference video for input. So one thing to note about these WAN models is they have a very specific aspect ratio and they have a very specific duration at which they work. So they were trained on 1280 by 720, so 720p, and they can generate about 5 seconds of a video. So that's like 81 frames a video. So we actually, for this experiment, we watched like a 20-second clip at the start. We've trimmed that down to 5 seconds and we've cropped it to 720p for this workflow to work at all. And Bruce, you've done a bunch of experiments of having those things not align or not have the exact frame rate. Anything for people to watch out for when they're starting this process?
I would say if you have an extra couple days to experiment, you can. There's interesting things that can be done by breaking the rules, but definitely just start off with 1280 by 720, 81 frames.
Great. So the next thing that we do in this pipeline is masking the character or the part of the video that we want to replace. And so what a mask looks like in this case, if we're just swapping the jacket, is we have ones in the frame for all of the things that we want to edit and zeros in the frame for all of the pixels that we don't want to edit. And this really helps the model focus in on we're just swapping out this information and we want to keep the rest of the scene identical. So if you're doing face swaps, if you're doing hair swaps, if you wanted to swap out the gun, this is really handy as a tool for you to have creative control. I know, Bruce, you used After Effects and some tools to generate this. There's other automated ways of doing it, like Segment Anything or these Florence 2 models. But any tips or tricks you would give people here?
I would say expand the mask a little bit beyond what you're trying to edit because it has to get that transition between whatever you're editing and the background. Or you can expand it in the Comfy workflow.
Cool. Yeah, so even expanding the edges and adding a little blur here lets the model transition between the external scene and the thing that you want to add. And then the final thing, what's cool about this VACE model is it can actually take multiple reference inputs. So we also decided to pass in a pose estimation model on Samuel himself, just to give it a little more hint as to where we want it to focus. Um, Bruce, did you run any experiments with just the mask or just the pose, or this is just kind of a tag team that you like to put in on people?
Yeah, this is kind of our default. There's other interesting models like you can extract depth information, and but the pose ones is very good when, especially like when once you start get faces turning and stuff because there's more detail there. But yeah, I would say start with this one if you're playing around.
Cool. And then the final piece that we put in this loop, and we'll dive into how all of this is chained into Comfy next, is training a LoRa just on the piece that you want to swap out. So, Bruce, I know you've worked on everything from trailers to music videos, and you're out here training LoRas for very specific parts of the workflow. Do you want to talk about like the different layers at which you can apply this and how many LoRa's you might use for a single shot?
Yeah, I would say that it depends very much on the artist, but we're looking at like you could have 4 or 5 LoRa's being applied. You can have things for the overall look, and we like to be like having a slider where you can dial the strength up and down is immensely useful. And yeah, I would say in a given shot, we might get something overall that looks good, and then you want to tweak what they're wearing, but you also want to tweak their expression. So you'll be surprised. AI is sold right now as this like one click make a shot, make a video thing, but it's AI with proper control is a bunch of talented artists working with good LoRa's that they've trained on and multiple LoRa's per edit and then multiple edits per shot. So it's still 10 times faster than traditional VFX, but it's a beautiful and complicated process.
Totally. And so, just to give you a bit of context of what the data set looked like for this and a couple of the iterations that Bruce and I did. For one, we were collaborating on this data in Oxen.ai or Oxen.ai itself. So we have this repository of Eddie Murphy Delirious. And the first one that I did out of the gate was I wrote like a quick Python script here to take a video in, chop it into frames, and then caption it with an LLM. And so you can see each one of these frames is a training data point, and each one of them has a caption, which was auto-generated by an LLM. This video itself came from YouTube and was actually pretty low res, pretty low quality. Definitely not that 720p. I think it's at like 480p. But I just wanted to see like, can the model learn anything here? Bruce and his skills came in and ran some models locally to upres every single frame. So we took these and upresed it to 1024 by 1024. And Bruce, what are some of the models that you used under the hood here to make that happen?
Yeah, we used a combination of Topaz has a lot of good stuff, and they actually have multiple models. So I actually used 2 different Topaz models. One made it look really sharp but cartoony, and the other one made it didn't go quite far enough. So it's 2 Topaz models combined, but there's also a lot of interesting open source stuff. I just use Topaz because I've been using it since like uh 2019 or so. And we use they have 2 different models. They have a video model and a stills model, and I've almost always found better results from the stills model, even if run on video frames. I think it just puts more computational power, and they expect you're going to be more patient. So just let it cook on a bunch of frames.
Nice. Um, So, yep, what we were feeling much better about this upsampled one. And if you're not familiar with Oxen, we give these datasets superpowers to either run LLMs over them or fine tune models. So, right from here, you can come in and fine tune a model. We have a bunch of different tasks. In this case, we're doing a text to video task, and we've got the suite of Wan models here. If you're using VACE, you're going to want to fine tune 2.1 T to V for your LoRa's. Um, if you do 2.2, that comes with high noise and a low noise LoRa. So stick to 2.1. Bruce, I know you mix and match these sometimes. Is that a good rule of thumb if you're using VACE to use 2.1?
Uh, what the thing is that the 2.1 model can also be plugged into 2.2. So I would say because VACE is so useful for doing edits, you're almost always going to want a 2.1 model. So it is worth it exploring if you have the time trying out 2.2, but I'd say the 2.1 is a good start because it works in 2.2 and you can use it for VACE.
Cool. So you pick your model here, you pick your input, you pick your output, or you pick your image and you pick your caption, and then you can also specify different things that you want to see generated while the model is training. We also expose hyperparameters here for your LoRa rank, your LoRa alpha, what time step type you want to take. And for this specific fine tune, we used 64 for the LoRa rank, LoRa alpha. We used 1500 steps and then a time step type of sigmoid because we're doing characters, batch size of 6, gradient accumulation of 2, and a learning rate of e to the negative 5, 7. There's 1, 2, 3, 4 zeros in front of this. And these are settings that you can play around with, settings that Bruce tweaks all the time. And I think this was from a previous character LoRa that you were running. But any intuition on these settings you want to share, Bruce?
I would say that this basically shows why you want Oxen because it's not a one-step process. This is a process of discovery and sharing. So these are good for now, but if you have a team working on this and you want to be setting multiple things to go, you don't want to just be cooking this on one sad, lonely, even if it's a Blackwell 6000, whatever. You want to be sending this to a supercomputer so you can have results, which is yeah, you want this thing takes a while on one machine and you might want to run it multiple times. So the moment you get into production work, it's an absolute no-brainer to do it on Oxen. I would, yeah. If we find new settings, we'll let you know. We'll have them in the defaults or something. We'll help pass them on to.
Love it. And so just to give you a sense of this model training on this data set, we started with a prompt here that was just like exactly from the training data set itself, or not exactly, but very close. And you can see the model has no concept of Eddie Murphy. It does have the concept of like a very shiny, reflective red plastic jacket, but not his plastic jacket. Um, Here we have more of like a Breaking Bad kind of plastic jacket. Here we have kind of like a model in hers and a model in his. And as we scan up, even after 200 steps, it's like, wow, okay, we have Eddie Murphy, we have the jacket, but maybe we have multiple of him. So it's already starting to pick up the concept, already starting to add a zipper to these. So it starts to learn pretty quickly already by 400. Now we've got him on the stand-up set. We've got this guy with the gun with a jacket that looks kind of like the one, but you'll notice there's some details here, like the way that the collar has a button at the top, etc. And as we go through slowly and slowly, it's picking up more features like that. Like, check it out. Now we have the medallion. Now we have the kind of buttons on the side of the jacket. So it's really picking up the concept here. And we felt around 1500 or 1400 steps was where it really started to nail it. So that's where we grabbed the LoRa from in this case. Um, Once the model's trained, the model weights get saved back to your repository. You can just download the safe tensors file and plug it into your Comfyui workflow, which is exactly what we're going to look at next. And I have a couple different experiments running here. This was the one that actually generated the video that we were looking at before. But before I hop into that, are there any questions from the crowd that we want to answer before we get into Comfy?
Craig, there was one question. It was just a bit back. You're kind of on a roll. But the question was, if the scope is limited to try-on only, did you explore Magic Try-on?
Have not explored Magic Try-on, but yeah, I think there's is that a video model or an image model? Does anyone know? We could look it up. Yeah, so if it's a image model, you definitely get the advantage in these video models of being able to pick up like the expression of the character or the way that the jacket moves in scenes. So that's one reason that you might want to fine tune your own. Um, and then can I follow along? Will you share the nodes? Yeah, we can definitely share this node workflow. And Casey asks, can we download the weights from other steps other than the final target? We're rolling that out this week. So right now you can download it from the final target, but we'll have checkpointing as we're going along. Cool. Um, so Bruce, this is like a pretty a workflow that you've done a few times. Is this a template that you like to start with and then tweak, or kind of walk me through where you start and where you start to tweak things?
Sure. This is coming from a collaboration. We've done a couple jobs with my friends Rory Robinson and Gary Tang, and these are quite readily shared around the internet. This is just a good starting template. Whenever you're working on a sequence of shots, it's good to have a clean template because you're often working in a team of artists. So this is just a good general starting point.
Great. And yeah, I'll tell you the I pinged Bruce on I think like Tuesday night, half a day he plugged in the nodes that we needed, and by Wednesday evening we had like a proof of concept. So starting with a template and starting with a workflow that you know works really well can allow you to move pretty quickly. So the first input over here is the video itself. You'll notice we make sure it's the exact resolution that we need. So 1280 by 720 and a frame count of 81. It's pretty important to get started. You just want to like reduce as many variables as possible here. So we resize it given those parameters just to make sure it's the right dimensions. Then we load in the other video of the mask itself. So the actual modeling or the masking step was done outside of Comfyui in this case. I know there are some like segment anything nodes and nodes that you could plug this into your exact workflow, but often we see artists liking the control of a tool like After Effects or something like that to really nail the mask here because it's a pretty important part of the step. After we have the mask, this is what Bruce was talking about earlier of growing the mask and blurring it. So there is a native Comfy node to do this. This is to add, you know, a little space around the pixels, a little blur around the pixels so that it can merge with the background a bit cleaner. And as we're going along, it's really nice to have these previews of what's coming in and what's coming out of these steps to help you debug, you know, did the masking work, did the pose estimation work, etc. The next interesting node in this workflow is taking the resized video from here and running it through a DW pose estimator model. Oh, and it looks like this actually isn't running right now. So let me spin this back up and we can run this thing live. Bruce, do you want to talk? I know you mentioned this DW pose estimator is a bit older of a model. Are there newer ones that you find interesting?
I would say that this is a interesting point of research because DW pose is quite simple and there's amazing papers on like poses for animals, and Facebook has like there's a ton of interesting things. We just this is an example of how limited things are at the moment, but how much you can do with even the most basic model. Like, I'm sure that someone smart is going to get onto Oxen and do a specific new fine tune with a new amazing pose model. And I mean, like, film, you're going to need a pose model for dragons and a pose model for this and the pose model from what if the animator wants to do something rough in a 3D application like Maya, and then they want to export that and we want to use this almost as 3D renderer. Like, so it's interesting how simple things can be and how amazing the results are and what all the stuff we need to do in the future.
Totally. So you can see this workflow is running right now. We have the DW pose estimator right here. I actually think I have one that's already run here. If we want to dive in and see what the output looks like. So I notice you use a lot of these video combine nodes to help you overlay the output of one model onto a video for debugging. You want to talk a bit more? I mean, this seems like a pretty powerful tool in the tool chain.
Yes, I mean, I think it's Comfy is a bit of a victim of its own success. I'm sure that they will have really good previews very soon that don't require you to actually go and make a little MP4. But for now, this is our way of seeing what we're doing, because it's also, if you look at the traditional tools that artists use, like Nuke or Result, like, we need to see what we're doing at every step. Because if it's working even vaguely right, you usually get a good result. And usually if things are not working, it's because it's not even detecting the person at all.
Yep. Yep. There's a lot of steps in this workflow, and each one is pretty important that you have high precision. The other one where I noticed you used video combine was the output of the mask onto the video. And is this one right here is doing the mask and the pose together. So you can see this is all black plus the pose. So that's not actually his suit underneath the hood. Okay, so that's kind of like all the input frames that we can put into Wan VACE itself. The other interesting things to dive into from an input standpoint are the acceleration LoRa here. So you'll hear this referred to as a lightning LoRa, and then the LoRa that you're fine-tuning from a service like Oxen itself. So Bruce, you want to talk a bit about the acceleration LoRa and anything to look out for there?
Yeah. I would say that the acceleration LoRa's are amazing because they cut down the time you can get to a quick result from many minutes to a lot less minutes. That said, experiment with them, try turning the strength down. Often they will interfere with things, but yeah, I would say experiment with them. There's no fixed amount. You'll see that they do interesting things to motion blur, and because they're trying to help it resolve it in less steps. But if you're going to run it without any acceleration LoRa's, it might take 20 steps, whereas this thing I think does it in about 6 steps. So this was a pragmatic choice for the current speed of the the fastest cards you can get.
And the difference between 6 steps and 20 steps might be like 10 minutes to an hour or something like that.
Yeah, it's going to save you 10 minutes, but often artists are iterating a lot and you're just trying different things and trying new masks. And I mean, so we need to be able to get that iteration time down as quickly as possible.
And that's something you're thinking about with Conductor as well, right? Like, what does the render farm look like for this so you can run multiple jobs in parallel, etc.?
Yeah, like a lot of this also, you have so many variables and you want to reduce your amount of variables so you know what the heck you're doing. And one thing is that the random seed will often have a very large impact on it. And so you don't know if you're tweaking this little slider of strength, but you don't know it just happens to be that random seed. So you can't, a better way to do it is you fire up this job and goes in parallel with a bunch of different random seeds. And you see, oh, okay, this strength does this across these different random seeds. Now let me tweak it. And then you get a better sense. You're kind of like you're flying an aircraft, but you want to figure out what all the controls do. And the solution to that is computation power.
Nice. And yeah, I know you tweaked a bit with the weight of the actual LoRa that came out of Oxen itself. What are kind of like ranges of values you look at there when you're applying LoRa's and kind of chaining them together like this?
In general, I would start with going between half and 1. That would be if things aren't working in that range, then there's probably something off with your
Cool. So once we have the LoRa's loaded, we then need to load all of the VACE models themselves. So we have the text encoder for VACE, the VAE or variational autoencoder, the model weights themselves. We put that all into a VACE model loader, encode the text prompt. And I know this was a pretty handy trick that you did even before we got started training, is trying to figure out what the base model kind of knows as terminology, so that you can latch onto that before you do the full fine tuning. So we saw this actually last week as well with the Quen image edit and swapping colors on desks. If you start with a a word that represents the color like sky blue, and then fine tune from there, that'll help you get like a really solid starting point, and then let the model fill in the details. So I wanted to give a quick preview of what Wan VACE did out of the gate without any fine tuning, because I think watching these different steps as we're going along is really informative. So Bruce was playing with prompting alone, and um, this is like a render of them side by side. And this is what, if you were just doing this whole workflow without the LoRa itself and saying shiny red plastic jacket, this is what you get, which is definitely like a shiny red plastic jacket. I don't know how many iterations you did on that prompt there, but is that a good framing for how you like to think about your trigger word or your starting prompt?
Yeah, because you can put in something like jacket or red leather jacket, and you want, just to save time, you want to see how close you can get the model to begin with, because often you'll find your training is kind of you're nudging the model in the direction of where you want to go. So you don't want to fight against the way the model understands the world. See if you can find a good starting point, and then you just give it a little nudge.
Yep, I like that as a way of thinking about it. So then that's the text that you're feeding into the model. We also encode the video here, like the raw video. If you traced this all the way back, that would be the video we have on the left. And then we also need to encode the frames from the mask and the frames from the pose estimation itself. So you can see there's one video VACE encode, these nodes here. And if you track them back, one of them is the mask and one of them is the pose estimation itself. Once you've encoded all of these into the latent space, we can now feed them into the sampler itself. And you'll see the sampler takes in different inputs from these models here. So Bruce, do you want to talk a bit about combining these and how you think about the sampler itself?
Yeah, I'd say the most important thing is don't, the sampler is incredibly powerful. You can go deep into the various settings of it. It's just, think of it like a scientific equation, but you're just trying to get the most important variables and you just want to leave some of the others as is. So you can try different schedulers, but I've seen artists mess with, well, this is probably a very scientific crowd, so they won't do this, but you'll absolutely get artists advocating for various kinds of magical numbers, or they'll think a specific random seed means something. And like, just treat it like a scientific experiment. Try and change one thing. Again, like, this is why you don't want to be running it on one machine. You want to be doing it properly in parallel.
Yep. And even things like dropping the seed from 42 to 40 gave us different results as we were going through. I think some of the failure cases are pretty illustrative as we're going through here. So let's look at a couple different iterations that we did. So I think this was the first model that you trained. And one of the funny things was since we trained it on Eddie Murphy with a microphone, uh, it tossed the microphone into this scene as well. And even the gun itself had a little cable here. So some things you have to think about with fine tuning is like, okay, what are the prompts that are going into the model? And if you noticed on the final data set that we had here, we specified Eddie Murphy holding a microphone with a cord in the training data itself, so that the model knows, when we leave that out at inference time, to leave out the microphone holding a cord. Um, you had a good phrase, Bruce, of like how you want to think about the prompts that go in itself. Can you talk a bit about that?
Sure. I mean, this is from working with a bunch of artists. They were trying to explain, they're like, well, prompt, like when you're training it, if there's something that you want to direct, make sure that's in. So if you're like, I might or might not want to have him holding a microphone, you should absolutely mention which frames a microphone is being held and which frames it's not. If it's something that you don't care about directing, you probably don't need to describe it as in detail. And like, so you'll get various people will say, well, prompt what you want to take out, but it's more like prompt what you want to be directable.
I like that. I like that as a frame of thinking about these prompts in the training data. So that was a hilarious failure case of turning the gun into a microphone. And then you'll also notice in here, like it still has his suit and tie underneath. And I know just swapping the seed from 42 to 40, same model, same LoRa. Now we have the proper red jacket and the proper, he has his little medallion under here. But if you'll notice in the last frame, we still have the cord on the gun. So yeah, some artists might think they have some magical numbers. It is really just random what the seed is, and tweaking these things and kind of seeing which seed seems to work the best for this specific model can be a handy tool in the tool belt. So that was kind of the first model we trained. Eventually, we added in the proper captions to have that control over the direction and plugged it in to the workflow here. We kind of mentioned at the start that we're working at 720p, and the original shot, if you remember, it actually had a bit of like it had this logo here because I just grabbed it from YouTube. It had these bars around it, and it wasn't 720p. So Bruce, if you want to talk about this final step of compositing the output back into the frames, I think this is super interesting too.
Yeah, this is a very common operation in visual effects where you take a frame and you crop out a little bit, you work on that bit, and then you stick it back into the frame. And it's one that I'm confused is not mentioned more in AI because it's so computationally intensive. You want all your compute power to go on what you want to edit. So yeah, you want to crop out a piece of the couple of the pixels, go make them look beautiful, and then you go and paste them back in over the old video. And it's one of the things I'm confused why it's not in every single AI tool and why we're putting into our conductor tool.
Nice. And yeah, like specifically, I know one of the questions we were asked is, I hear Wan only works at 720p, but I need 4K resolution. Well, if you think about that problem and you break it down into just the subsection of the video that you need to edit, that allows you to get away with 720p, but in the context of a bigger frame. Cool. So this was the final output here. You can tell that the lighting is actually super consistent. The shadows on the jacket itself, the way that the jacket moves, no longer kind of looks plasticky. In this particular one, it looks like his the zipper got replaced with his medallion. So we did do a bit of playing with different random seeds. And the best one that we've come up with so far, and granted, this was like a day and a half project, so pretty impressed with the results for a day and a half, is this video right here. You can see the medallion is now under his jacket, and as it moves, it even like shifts it over to the right a bit. He raises his gun, looks at it. Like this is pretty high cinematic quality for half a day of work. So pretty cool where these models can get you. And yeah, excited to see where Bruce takes this in a more automated fashion with his conductor tool. Any last comments, Bruce, or wisdom you want to share with the crowd?
I mean, thank you. This was a ton of fun. Yeah, anyone have any questions?
Cool. If you guys do have questions or you're watching on the YouTube afterwards, feel free to join our Discord
Yeah.
and we're happy to answer them there. But we
I
do
see
have
one about color gamuts and log spaces. Uh, I own an Alexa. I love shooting in log. This is right now the models are just working in good old fashioned Rec 709 sRGB. So basically in filmmaking, the filmmakers don't like to work in this restricted color space where the bright information and the dark information can be quite easily clipped out. So when they're filming on their cameras, they want to contain the full color range, and then so that they can go into color grading suite and they can like beautifully go and adjust everything after the fact without losing all the detail. And then traditional VFX works in that color space as well. The short answer is that right now, the way to do it would be to be careful about your input, that you're not clipping the far black and the far white image. And if you work in that way, and you can use various professional tools like OpenColor.io, etc., you say, okay, I'm going to take it. It's like, for example, when you're working on Marvel films, you'll have a matte painter, and the matte painter will work in traditional good old-fashioned sRGB, and then it'll get put into a pipeline with this expanded color and luminance range. So I think this is an interesting topic for further clever Oxen fine-tuning, figuring out how we can translate all this knowledge to a naturally high dynamic range or log format. Right now, you basically deal with it like in a visual effects way. A lot of our visual effects under the hood is actually working in sRGB, so it's not the biggest problem. Is that too short? Oh yeah, to log space. If I was dealing with this, I mean, I've done this where I've got shot on an Alexa in log space in and I need to use Topaz to upres it, and Topaz doesn't really understand high dynamic range. We deal with this all the time with various upres AI tools and noise reduction AI tools, that they actually work better in a traditional color space. And the short answer is we just figure out how to get all the detail and not clip it out. We convert it in from the log space into the correct space for the specific app, and have it do its work, and then we reverse that to get it back in. And the main thing is just not clipping your highlights and not clipping your shadows.
Cool. What about, this is a good question, with the VACE takes reference image as input, did we attempt providing the jacket as a reference image instead of the training? Can you talk a bit about reference images versus training?
Sure. you'll notice in our workflow, we just have the default Comfy image as our reference image. In a more advanced context, you would absolutely want to use both. I don't think that providing a single reference image is as powerful, especially when you're going and characters are moving around and you're seeing multiple shots. It's still very powerful, but I would say use both.
Cool. And then curious if the LoRa you trained would generate eddy if used without VACE.
Yes, I mean, that's an interesting thing of there's a lot of other steps that you want to do. If you want to be generating, you want Eddie in a red jacket, and then you want different characters all around them. You want to be doing regularization steps. You want to be doing a whole bunch more tricks in your training to make it kind of hone the LoRa down so that it doesn't just transform the entire world into Eddie Murphy, like being John Malkovich land where they're all beaten. So yes, the short answer is we knew what we were doing. We knew we were going to use VACE to do a replacement, and that replacement would be guided by the mask. Therefore, we targeted our training on doing a good replacement. So if it transformed the entire world into Eddie Murphy, that was just a fun side effect. So yeah, it basically showed. I mean, every job we've been doing, we have you've got artists doing shots, and then you have other people training, and they are training throughout the job, and they're doing versions of it, and they're so this could be a thing of we're doing this shot, and then oh crap, we realized we need to go and do a wide shot where we do a synthetic Eddie Murphy among other people. Then we'd have to do a new training, which might take 3 or 4 times the computation power. So it's an interesting trade-off, and it just shows how like training is not like you're going to get some pre-packaged thing. Like it's an organic process that is very much going to be part of creative filmmaking.
Cool. Thanks for sharing this Quen image edit, multiple angles to Casey. This is pretty cool. All right. Well, thank you, Bruce, for giving us a little sneak peek behind the workflows that you're doing. I hope that was super helpful for the community. And yeah, excited to see what you build with Conductor. It's a cool problem you're solving.
Thank you so much, Greg. It was just so much fun.
All right. I'll see you guys later. If you're watching on YouTube, thank you for watching and feel free to share with your friends. All right. See you guys later.